So a few videos ago, when we were doing factoring, we looked at this problem. And we tried to factor it as we usually do with a coefficient other than 1 in front of x squared. We find the factors of the 2, and then we find the factors of the 5, and we see if when we multiply it across and then add the two results, we'll get 8. And here we would get 10 plus 1 is 11. So then we try it with a different combination, and we get 5 plus 2 is 7. And so these were the only two combinations, so we concluded that this problem was not factorable. And occasionally you will run across problems that are not factorable, in which case you need to use one of two other methods to solve quadratic equations other than factoring. And the one we're going to go through in this video is called completing the square. Sounds like a big fancy process, and it kind of is. It's a bit complex, but we're going to go through it nice and slowly and make sure you understand exactly what you're doing. So let's start with an easier problem than this. X squared plus 6x plus 7 equals 0. So, if we were to try to factor this, we would be finding two numbers that multiply to 7 and add to 6. And you can clearly see that there are no factors that would do that. So this problem is also unfactorable. So completing the square is what we're going to use to solve this. Let's bring back this good old formula that we've been using. So, should look pretty familiar by now. I believe this is the third video where we're using this. And we're going to use this formula to explain how completing the square works. So, x squared is the a squared term, and 6x is the 2ab term. That's all we're going to focus on for now. Leave the 7 out of it. So, let's just assume that we had a b squared term. It's not 7. 7 we're almost treating as just separately. We had x squared plus 6x plus something would be a squared plus 2ab plus b squared. So if we had that, then we could use this formula, as we've done in previous videos, to put that problem into a plus b squared. So that's exactly what we're going to do. So if a squared is x squared, then a will be x. If 2ab is 6x, then b will be, so it'll be 6 divided by x divided by 2, which is 3. We went from 2ab to b, so we took out a, which is x, and we divided by 2. So we get x plus 3, and then it's x plus 3 squared. So that is the first step in completing the square. We changed x squared plus 6x to x plus 3 squared. But there's a problem here. If you notice, if we were to simplify this back out, going from the a plus b squared back out to this, we'd get x squared plus 2 times x plus 3. So x squared plus 6x plus 9 when we do the 3 squared. Where did the plus 9 come from? Well, we actually just added that in there. That wasn't part of the original problem. The original problem, we just had the x squared plus 6x here. Remember, we're ignoring the plus 7. So we ended up adding a 9 by doing that. So that's okay. What we're just going to do is take out the 9 that we added in. So now we'll have x squared plus 6x plus 9 minus 9 goes back to x squared plus 6x. Okay, good. So all we've done is changed x squared plus 6x into x plus 3 squared minus 9. Now, don't forget about the plus 7 that we've kept separate over here. And the whole thing is still equal to 0. Okay, that is step 1 of completing the square. The next step is you want to set this x plus 3 squared term equal, you want to get it by itself. So you want to get it by itself on this left side here. So to do that, we're going to move everything else over. So negative 9 plus 7 will be negative 2 on this side. Move it over, it will be positive 2 on that side. Now, in order to get rid of the squared here, we're just going to take the square root of both sides. So the square root of x plus 3 squared is just x plus 3. And then we'll have square root of 2 here. Now, one thing I haven't mentioned yet about square roots is that when you take a square root, you want to put plus minus here. The square root of any number can either be the positive square root or the negative square root. And here's why. When you multiply a negative number times itself, it always goes back to being a positive number. So in this problem, negative square root of 2 times negative square root of 2 would be positive 2. So when you're taking square roots in a full algebra problem like this, you want to remember to do that. And you'll see why in just a second. So now we'll move the negative 3 over here. We'll get x equals plus or minus the square root of 2 minus 3. So the reason we needed the plus or minus is because, remember, with these quadratic equations, with most of them anyway, you will always have two solutions. If you don't put the plus or minus here, then you're only looking at the solution, you're only looking at one of the solutions. You need to put plus minus here to show that there are two solutions. The two solutions to x are square root of 2 minus 3 and negative square root of 2 minus 3. And there we go. We have just solved for x in this problem. So really the reason it wasn't factorable is because we ended up with factors that would have had square roots. So if you're going to end up with factors that have square roots, then the problem's probably not going to be factorable, and you're going to have to use completing the square like this. Okay, so hopefully you understood most of what we did there, but we're going to do several more examples of this level so that you fully understand what we're doing before we move on to anything harder. Okay, so just to go through how this formula works one more time. We're changing a squared plus 2ab into a plus b squared. So if a squared is x squared, then a is x. And if 2ab is 8x, then b is 4. So really what it is every time is it's x, it's the square root of this a squared term plus half of this coefficient, and then there's no x. That's the pattern here, and you will get very used to doing that after you do enough of these problems. So we have, if we were to simplify this back out, we would get x squared plus 2 times x times 4. So that's x squared plus 8x plus 16. Now, where did the plus 16 come from? Well, remember, we added that in when we converted x squared plus 8x into this, so we have to take it back out. So x squared plus 8x plus 16 minus 16 will be back to just x squared plus 8x. And remember, we didn't use this plus 11 at all, so we have to remember to write that in here as well. Now from here, it's just the same process. You put the squared term by itself, so negative 16 plus 11 is negative 5. Move it to the right side, we'll get positive 5. You take the square roots of both sides, so x plus 4 equals the square root of 5. Don't forget plus or minus. Move the 4 over, x will equal plus or minus the square root of 5 minus 4. So this is what completing the square is. It allows you to solve for x in any quadratic equation that is not factorable. Or you could use it for quadratic equations that are factorable as well. Now, factoring is probably faster most of the time, but this works for all quadratic equations. You will never come across a quadratic equation that cannot be solved using this method, because all we're basically doing is gradually isolating x by itself. Okay, let's bring in some negative numbers here. Again, once you learn the steps, it's just the same over and over. Ignore the minus 16 and look at x squared minus 12x. It's always going to be x plus half of this negative 12, so x minus 6, right? Because a squared minus 2ab, the minus sign here, a squared minus 2ab equals a minus b. So keep the negative there. X squared, x minus 6 squared. So if we were to simplify this back out, we'd get x squared minus 12x plus 36. The plus 36 is what we ended up inserting into this problem, so we have to take it back out so that it's back, this whole thing is back to being just x squared minus 12x. Then we write the minus 16, and we have this. Now from here, we isolate the squared term. Negative 52 on the right side will be positive 52. Take the square roots. Square root of 52. Remember that this can be simplified into square root of 4 times square root of 13, which is 2 times the square root of 13. And remember to put plus or minus in front of the whole thing. Move the negative 6 over, and we get x equals plus or minus 2 times the square root of 13 plus 6. So just so you're clear, the two solutions to this would be 2 times the square root of 13 plus 6 and negative 2 times the square root of 13 plus 6. Okay, so if you are not fully understanding those problems that we just did, I would recommend that you go back to them and re-watch how we did them so that you fully understand the steps, because this next problem, although it might not look like it is going to get harder. So it's important that you don't move on until you fully understand what we're doing. Reason is because now when we take half of 3, we're going to get a fraction. We're going to get 3 over 2. So x squared plus 3x will change to x plus 3 over 2 squared. Remember, we take half of the coefficient of x. X plus 3 over 2 squared. So now what's the number we added in here? Well, this would simplify back out to x squared plus 2 times x times 3 over 2. 2 times 3 over 2. The 2 times 2 divide by 2 cancel out. So this is 2 times 3 over 2 is 3. So this is x squared plus 3x. That makes sense because that's right here. But then plus 3 over 2 squared, which is 9 over 4. So 9 over 4 is what we have to take out. Now this plus 1 that we're going to bring down here, let's convert it so that it has the same denominator as the 9 over 4. Let's make it plus 4 over 4. That's just going to make things easier in the long run. So now, bringing all that stuff over to the other side, negative 9 over 4 plus 4 over 4 is negative 5 over 4. On the other side, it will be positive 5 over 4. Now we'll take the square root of both sides. The square root of 5 over 4, the denominator is a perfect square, so it's just going to be 2. So this will be the square root of 5 over 2. Don't forget the plus or minus. Now, here's what you should notice here. 3 over 2 and square root of 5 over 2 both have a denominator of 2. So here's how we can write this. Instead of writing square root of 5 over 2 minus 3 over 2, we're just going to write square root of 5 minus 3, that whole thing over 2. We just combined those fractions. Now here's what's very important. Only the square root of 5 over 2 had a plus minus. So the plus minus does not go in front of the whole fraction. Extend the numerator out here. It only goes in front of the square root of 5 part. Because if you were to put it in front of the whole thing, then it would be applying to the 3 over 2, which did not have a plus minus here. So this, be very careful that you write it the correct way. This is the answer. X is square root of 5 minus 3 over 2, or negative square root of 5 minus 3 over 2. Okay, we're going to do one more problem in this video. So, here we do x, since it's minus here, it will be x minus half of 5. That's 5 over 2 squared. So if we were to simplify this back out, it'd be x squared minus 2 times x times 5 over 2, that's minus 5x, plus negative 5 over 2 squared is positive 25 over 4. Remember, negative squared is a positive, so negative 5 over 2 squared is positive 25 over 4. So in order to get rid of that, we take out a negative 25 over 4. Because remember, that was not in the original problem. That got added when we converted to this form. And we'll change the plus 7 that we bring down to have a denominator of 4, so it'll be 28 over 4. Move that stuff over to the other side. Negative 25 over 4 plus 28 over 4 is positive 3/4. On the other side, it's negative 3/4. Now, when we take the square root of both sides, we're taking a square root of a negative number, which means we have to use an imaginary number. This is why we learned those here. So the square root of 3/4 would be the square root of 3 over 2, right? Because the square root of 4 is 2. So this would be the square root of 3 over 4. Oh, I'm sorry, square root of 3 over 2. But because it's negative here, it's I square root of 3 over 4. Negative 1 times the square root of negative 3. Square root of negative 1 times the square root of negative 3. And then, don't forget the plus minus symbol. Here, let's see if we can squeeze that in there. The plus minus symbol. For any square root, it's always the positive or the negative square root. Now, when we bring over the 5 over 2, once again recognize that it has the same denominator as this fraction, so this will be I square root of 3 plus 5. The negative 5 changes to plus 5. the whole thing over 2, and the plus minus of the I square root of 3 only applies to the I square root of 3. So remember to write that in front of the I square root of 3 in the numerator, not in front of the whole fraction. Okay, so this is an introduction to completing the square. We will be doing a lot more of completing the square in future videos.